Hi, good afternoon. I think we all are awake after the sumptuous lunch and after wonderful delivery by Ramdasaji on the fuel cell technicals. So I tried to focus now on the second part of that part is like a green energy transition or energy transition as such. Before going further, let me introduce myself. I am Sudhir Pathak, taking care of design, engineering, quality assurance, and green hydrogen initiative in my organization called Hero Future Energies. And we are the renewable arm of the Hero Group company. You must have seen a lot of bikes around there. Yeah, and on my personal capacity, I'm having 28 plus years of experience, out of which 27 years all into the power sector, with my greatest alma mater, NTPC, for several years. And then Welspun, Acme as CTO, and now with Hero Future as CTO. So I'm really elated that we are really into hugely interesting times when we are in a phase where we are trying to transit the energy into a good phase or a better phase. I remember that even this green technology was costly, means you can say it was viable in 1930s, if I remember. In 1930s, green hydrogen was already in production through hydroelectric power being pumped into alkaline technology. But after that, techno-commercial came into the picture. The discovery of coal, natural gas, and all this became the spoil sport. And then we transited into the lower or cheap economy, but it was not good for our Mother Earth. So I think if you can project the first, this one. Thank you. So before going further to that, so let me make a pitch that our Earth or our atmosphere here, it is beyond boundaries. So the environment is common to all across the globe. And fundamentally, if I just move to the first one, this slide simply says we have already missed the bus, the first bus, where we can limit our temperature, our Mother Earth's temperature, 1.5 degrees below the pre-industrial times. Because we are running around, we are just trying to guzzle up the consumption of the fossil fuel-based energy around. So it's the right time that we should plunge into it. And we are fortunate that we are one of the drivers for this. So I don't know if it is visible much to all of you, but I just wanted to showcase that maybe many of you already know that IPCC has given various nomenclatures called RCP, right? So which is representative concentration path, which has been defined, different numbers has been given. So RCP 1.9, if I say that this is what we have already surpassed, where it says about the ambitious target of limiting our temperature by 2100, or you can say by 2100, end of this century, the limitation of the Earth environment average temperature by 1.5 degrees. So that is called RCP 1.9. What is this 1.9? There is an energy balance on the Earth's atmosphere that is called radiative forcing. So that whatever energy we take from sun, and then whatever, some of them is absorbed in the atmosphere, some of them is absorbed by the Earth surface, and some of it is reflected. So there is a continuous balance. So whenever this balance is disturbed, either Earth goes to the cooling direction or it goes to the heating direction. So incidentally, by fossil fuel, we all know that GHG, greenhouse gases, wherein the whatever Earth radiates out of the atmosphere beyond the stratosphere, that gets entrapped by our CO2 and all those stuff. And that leads to increasing the temperature, and that disturbs the heat balance. Or radiative forcing is the 1.9 watt per meter square of disbalance that happens. From there, that comes out to be 1.9, which is actually aspirational for that matter. So now on RCP 2.6 is again 2.6 is watt per meter square, wherein we need to start declining the CO2 emission by 2020, which has already gone to us. Okay, so that means here also we are running behind the schedule. Then only we will be able to contain our Earth's temperature rise up to 2 degrees. So, in my opinion, that is also aspirational, but not impossible. Looking into like all the, you can say, the denizens of this, we are actually the, you can say, sons and daughters of Mother Earth. And as of now, in our bank balance, we have only 580 gigatons of CO2 to be emitted, wherein we are really behind the schedule, and our Mother Earth should not go to the ventilator because her temperature is rising. So we should try to conserve our bank balance of CO2 emission. So what I perceive that RCP 4.5 looks to be a more fathomable target, but we should aspire to RCP 1.9. So it is not only CO2, it's about methane emissions also, like to be half of whatever we are emitting by 2020. Even SOx also, and then very important part that by planting more trees, or even like in our earlier discussions where one August panelist told that we should bring or have a section of the CO2 from the atmosphere which can be utilized for generation of methanol and all. So that can also help us in going to negative carbon. So this is what the impact can come on, which is on phenology, or the changes in the biodiversity. On our ecosystem, second thing, that even species need to be adapted to themselves. And that can, again, Darwinism, the survival of the fittest. You will see many species going or vanishing away, and lot of things will start happening. On human system, definitely the food scarcity and the water scarcity, you can see in UK what is happening. It's very, very hot. Even now people are thinking to put air conditions into their houses in UK, which was never dreamt of. And definitely like city settlement and infrastructures is going for toss. So slightly crowded slide, but it gives a glimpse of what is going to happen. It is trying to give a kind of a scenario that at different stages, what is going to happen on physical system, biological system, and the human system all across the globe. It is slightly crowded, but it just gives a view that what is going to happen to our glaciers because of the temperature and all those issues. And the rivers, lakes, they will start getting flooded. Our coastal erosion will start happening. And all those aspects, if you start looking at it, so it is really a gloomy scenario as of now. Now, coming to CO2 emissions globally, as I told that we have as of now only 580 gigatons of CO2 in our bank balance globally. And every year we emit approximately 30 gigatons. So just by doing a simple math, you can see that we have only 15 to 16 or even maybe 20 years left. What we are going to give it to our younger audience there for the future. So they must be blaming us for all the bad things we have done on the earth. It's the right time for us to move on. And if you see where are we as of now, if I focus on Indian scenario, so we are not the worst, but we are not the best. We are, as of now, we are the third most polluting, emitting country as of now. So this is it's a huge roadmap for us to move ahead. Yeah, coming to the CO2 emission composition. So you can see that a power sector or you can say the thermal-based, coal-based, slightly gas-based, they are the most polluting industry on the earth as of now. So, which approximately 40% of the whole composition of CO2 emission. Remaining is by industry, then transport, then buildings, and something else. If you see on the bottom line, so iron and steel, cement, heavy vehicles, trucks, when I say heavy vehicles, so our last knowledgeable panelist told about the high heavy-duty vehicles. So these are the guzzlers of you can say CO2. So coming to Indian energy mix, why I'm showing this because the next slide will be very interesting for all of you. We can see that whenever we say energy, people mostly confuse that with the power. But you see that if you see in this graph, the right side blue line is a small pie out of it. It is only 40% energy which we consume for generating electricity. Remaining 60% comes from which we utilize for our different furnaces, even vehicles, and lot many things. If you see that, if I take the name like all crude oil, whatever we use, or hydrogen, what we generate for refineries, all through SMR, which is again emitting CO2. So yeah, I've already told about that. So let me move to the important. This is very economical, or from economics perspective, we are almost shelling out $130 billion every year for importing crude oil or the natural gas. So this is one of the biggest advantage in case we are able to decarbonize. This is very important because like now I'm an applicator, because like ARI is a researcher and other August panels are researchers, or they are developers of fuel cell technologies and other technologies. We are the applicator, and we are talking to various end-use clients, C&I markets, to gauge their understanding, their need. So typically whenever we say net zero, so before net zero, it comes RE100. What is RE100? If you see scope 2, there are different scope has been designed. Scope 1, 2, and 3 are being defined by IPCC, on a pathway to decarbonize. So when we say scope 2, so that means if you see that whatever electrical energy you are importing from the grid, from the third party, for your primary consumption, that is basically scope 2. So typically, most of the industrial customers or anywhere, whatever you look, they are buying conventional power from the grid. So now they've started decarbonizing. That is also kind of decarbonizing, but they are trying to replace that with RE either by BTM, or what is called behind the meter, putting rooftop solar or even ground mount solar, or purchasing the open access power and all those stuff. But the problem is here. If you see RE0 to RE40, typically I've just taken from experience, you can fulfill up to 40%, you can say, displacement of the gray power by only having solar and wind, plain vanilla solar and wind. But as you move ahead up to from RE40 to RE70, so there are some innovative policies around called banking, where you can virtually store the power with the discoms, and which you can take back during your need time. But this banking is a very fragile policy which can go away at any time. So it can be a menace for that investment, although it is very useful as of now. So we can go up to RE70 by banking and exchange, by having all innovative exchanges what we have. Beyond 70, that is called last mile, or you can say last mile connectivity, what we term as. There you need definitely storage. And when we say storage, it can be anything. I think it can be battery, whatever typically code name storage with battery, but I say battery is agnostic of the technology. Either battery storage, or you can say even pumped storage, or even with hydrogen storage. So after this, now the path starts for scope 1 and 3, which is called path to net zero, or 100% decarbonization. So scope 1 and scope 2 is like wherein that remaining 40% of the part comes out, which is like utilization of hydrogen or electric vehicles and all that stuff. So slightly giving a very different view about, like if you see that we are very happy as of now that yes, government has announced 500 gigawatt, or they have given that, okay, we will be limiting our emissions and then making everything is gung-ho. But there is an inherent problem. If you analyze the data that about Indian grid, about the balance between demand and supply, if I go up almost 10 to 12 years back, so if you can see, do you have any marker here? So if you see that 10 to 12 years back, the deficit during energy was as high as 10%, and even during peak was 12.7. If you go to the bottom line, if you see that the deficit is now nowhere. There's no deficit. Our peak demand is being met. Our energy supply is being met. So even with this solar and wind and the thermal power plants, we don't need anything extra. So why at all are we doing this? So if you take the second slide, that is the pain of our base load station, which is my alma mater's NTPC thermal power plants, or if it is any state thermal power plants, or anybody's. See the PLF at which they are running. So whenever in my times when I was working with NTPC, that we used to put our collar high by saying my PLF is above 100%, right? We used to guzzle as much power as possible into the grid. But now I can understand the pain of my fellow people there, that they feel so pained that now their PLF is 53%. So that's the problem. Now, what to do? If you see this again, that today we are, from installed capacity, we are approximately 25% of RE. I'm saying RE, solar and wind. Overall, it is 40%, and our fossil fuel is 60%. So we are 60-40 ratio, right? In which 25% is intermittent, which is RE. And from energy perspective, because of the PLF and CF issues of the intermittency, it is solar wind is only 13%. And today we have a problem, right? Just imagine the future when our solar wind share will become 51% and energy will become 35%. So our problem is statement that we are having our resources which are inefficient as of now. We are just putting it as a plain vanilla. There is a huge problem of dwindling grid inertia and fault resilience. There was an outage of 6 gigawatt in Rajasthan grid of ISTS when there was by a single fault in a grid, the complete 6 gigawatt of solar and wind got into toss. So that's why our grids is quite vulnerable. If you take steady state, transient, and even dynamic state stability issues, now we are going to be living in an era where some 15 years back when I was quite young, like those friends that are sitting out there, every month I used to see the grid failures. But then there came an ABD regime where Bhanu Bhushan Saab gave a vision of grid stability, and automatically everything came down and became very stable. So we need to change the grid chemistry as a way forward, like by having the storage into the system, either pumped, battery, mechanical, or generator. So I will take 5 more minutes. Yeah. Okay, sure. So, now coming to the brain behind it, like what are the paths of decarbonization? So we have to make this transition sustainable. Just blindfoldly we can't run and make everything RE. We have to make that it is sustainable, because one grid failure or national grid failure is, we can say, millions of dollars every hour which we lose. It has to be sustainable. So now from that perspective, we have to think from that line, and then I will, in case we say that what are the pathways to this thing. So first of all, it is not only energy, it's also feedstock, because we use hydrogen as a process in the chemical industry, in refinery, in fertilizer, definitely. So then definitely fuel replacement. We all know that hydrogen or methanol or ammonia, definitely CCUS or carbon storage and its utilization, and then mobility definitely. In mobility, we discussed about EV batteries and hydrogen. My fellow panelists explained a lot about it. I will not speak for it, but just 2 points I want to put here. That one is fuel cell, but now for quick decarbonization, because fuel cell, I know that economy is not working out as of now. Its total cost of ownership, or TCO, what we name as of now, it is not workable, and whatever you want to multiply, you can't multiply unless it is techno-commercially viable. So as of now, if you see that approximately somewhere 23 liters per 100 kilometer of high-duty vehicle they consume, and whereas the hydrogen for that, it's somewhere 6 to 7 kg per 100 kilometers it comes. But it's a 3 times or 2 times difference, but if you see because of the calorific value or the MMBTU perspective. But the cost still it is somewhere if you take the LCOH delivered, LCOH delivered is approximately, you can say it is somewhere coming to be 13 euros. 13 euros, it is coming as an LCOH for running per kg. So we need to go into dual fuel where at least we can get a push to mix in the existing IC engines a quantum of hydrogen, which can even up to even I think 20, it can improve the mileage also, and also it can easily retrofit in any kind of vehicle. Fuel cell vehicle, fellow panelists already explained, and then I understand IC engines are also under invention. They are under final stages of, so IC engine which can run 100% on hydrogen. So I think these 3 technologies will come together. First of all, immediately fuel, the dual fuel can come on 4. Then fuel cell vehicle definitely, and then IC will be all pervasive. DRI definitely for reducing agent, and then green ammonia. Green ammonia also can be used, apart from fertilization, it can be used for transportation and as fuel. So coming to almost last of my slide, that yes, these are the main challenges. First of all is definitely from my applications perspective, when I go to any kind of C&I customer, the first question they ask, can you make this solution cost competitive as compared to my whatever I'm using? So I say, sir, humbly speaking, no. If hydrogen could have come to the LCOH of the energy equivalent of your natural gas or LPG, the whole world could have replaced with hydrogen. So please be the first runner into it. Try to pitch in and take the ESG funding, take the brand name, and then you will, that is what I keep on telling them. So as I told, LCOH has 2 parts, which is called generated or whatever we get just after the electrolyzer, where the 2 parts are very important, cost and efficiency of the electrolysis. It is only maybe 60%. Now the stationary application of SOEC is coming out, which is touted to be 90%. I think I'm quite bullish on that. LCOH delivered, I've already explained, is very costly because of high compression and storage cost and also high liquefaction cost. These are 2 technologies which are running and trying to fight with each other, but let's see. Definitely there's a lack of demand creation mandate, although in refinery sector, being a rich sector, they are working on their own, but there is a huge mandate needed for to make it all pervasive. Water we need of approximately 700 gigaliters by 2050, right? So just imagine the quantum of water we need. It is a huge problem, so what I expect that, and yeah, I told about the transportation, 700 bar, it's a huge pressure which will go into public domain. Just imagine people sitting below a 700 bar cylinder on the head top. So safety norms, central state policy consistency, and the cost of desalination, because that 700 gigaliters will come not from the ground, it has to come from the sea. So there will be chain of desalination plant will come around the eastern and western coastal line of India. Safety norm definitely, and definitely last but not least is financing. Because as of now, our lenders, investors are slightly wary about how much it is workable, how much it is acceptable. Just moving, so my slide that whatever has come down from rocket to scaling, that goes exponential. Initially, the modules were the aesthetics of satellite or the rocket mounted things. When it came to solar panels on the ground, the tariff came down to ₹2 or even less. Now it's the time for hydrogen story. Rocket has a primary fuel of liquefied hydrogen. So once it comes to ground, I know that it will have a replication story of solar. So that's my pitch. And I am firm believer that yes, the time is going to come when we may see 111. Thanks.
Thank you. Thank you.